screen. So last class, we kind of talked about hypothesis testing. So we went through the basics and the steps of doing a hypothesis test. We talked about the type of errors of a hypothesis test, right? And that was all in 8.1. So we went through all the steps, talked about the different types of errors. We did a proportion problem. And so you can see all that work is still on my OneNote. And so today, we are going to do two other examples. We are going to do a hypothesis test on the mean, which is section 8.3. We are going to do a hypothesis test on the variance, which is section 8.4. On Tuesday, I will show you how to take raw data and go from start to finish of a hypothesis test. And you will not have to do that on the test. I think there is a homework question like that. But we'll go from start to finish, from raw data all the way to the end. So we'll do that on Tuesday, and we'll finish, and then I'll use the rest of the class to answer any questions you have before the test. So remember, hypothesis has the steps. So we're going to go through all the steps. I already have space for us to go through them all. And we're going to go through this problem together. So the average student loan debt in Maine is $31,364 according to the Motley Fool website. I think the debt is lower for students who attend USM. So a sample of 100 students from USM said that their debt was $29,398 with a standard deviation of $780. Conduct a hypothesis test on the average student loan debt in Maine at a 5% significance level. So how do we know what type of problem this is? What are some of the key words here?
Average.
Okay, so we see the word average, right? So that tells us it is a hypothesis test of the mean. Perfect. We also have the word hypothesis test, right? So that tells us this is a hypothesis test problem of the mean, right? So now that we know it's a hypothesis test, we know step one is to define the null, H naught, and our alternative, HA. And so we know it's an average. So what symbol do we use?
Wouldn't that be the alpha?
No, alpha's always our tails.
Oh, that's right.
What symbol is of the mean?
Mu.
Mu. So we know it's going to be a mu symbol, so I want to put that in both of them. And remember, the null is always equal, and it's equal to what we believe to be true, right? And what we, the society, not the person doing the analysis, believe, all right? We're going to base it off the website that the average debt in Maine for our student loans is $31,364. So that is what my null equals. But whatever value is in my null is also, in my alternative, right? So I don't use the new number I think it is. I still use the same number from the null. What I now have to do is figure out what inequality I want, right?
Less than.
I think it is less than, right?
Less than.
Yeah.
So I think the debt, yeah, lower. There we go. I was looking for the word. Lower. So we are doing a less than problem. All right, so there's step one done. And you can see part of step one was knowing your significance level, and it is right there given to you, a 5% significance level. So that will come back to play later. But we have everything we need to know. Go lay down. Bless you.
The puppy wants to learn statistics too.
Yeah. The puppy wants me to play with her. All right. So now, why aren't you doing what I want you to do there? We're going on to step 2, right? So step 2 is get your test statistic. Well, we know we're doing a problem on the mean. We know we are in chapter 8. So that means I take my pullout and I go to chapter 8 and I find my test statistic of the mean. And there is 2 of them. There is the mean with sigma unknown, and there is the mean with sigma known. Which one do we always use?
Unknown.
Unknown. So my test statistic is t equals x bar minus mu all over s over the square root of n. And just like I've said before, I would put in my parentheses. There should be a parentheses up here so you don't mess up the calculations. And there should be a parenthesis in the denominator so that your calculator does things in the proper order. Our little buddy here in the denominator, right? What does that remind you of?
Which one? I didn't see what you were pointing to.
Our denominator of our test statistic. That should remind you of something.
The headache I have after this class?
That it might be it as well. That could be a correct answer. The central limit theorem.
Yeah.
Yeah. We're finding the new standard deviation based off our sample size, right? So we always have to make sure our sample size is what? Greater than what number?
30.
30. And in our case, I sampled 100 students, so we are good to go to use this formula. So now we just start putting the numbers in, right? So x bar is what number?
It's gonna be 29,398.
It would be. It would be my sample average. Okay. What's my mean value?
31,364.
Yeah, it's what my null is equal to. All right. And then my standard deviation?
0.05. Oh, nope, 780.
Perfect. And my sample size, we already said, was 100. And I have to take the square root of that number. And I put all that in parentheses. And then I go find my trusty calculator. And I type this in. So, parentheses, 29,398 minus 31,364, close parentheses, divided by parentheses, 780 divided by the square root of 100. If your square root requires a parentheses, this is where you close it. If it does not, just make sure you're outside of the square root, close the parentheses to keep everything in the denominator, and then hit equals. And I get a huge test statistic of negative 25.205. And that's not a comma, it's supposed to be a point. Did anyone else get that answer before we move on?
Yes, I did.
Okay, good. But I haven't tested this problem. I just came up with the problem. I'd be smart one day if I actually did the problems before class. So step 2 is done, right? Step 2 is to find our test statistic. So there is our lovely test statistic. Step 3. Step 3 is to draw our picture. What distribution am I drawing?
The normal one?
Not normal.
You.
The T. How do I know I'm drawing the T?
It's in the formula.
It's in the formula.
That was
Don't
right.
overthink this. It's in the formula.
I
The
overthink
formula tells you.
everything.
I know. So formula tells you what distribution you're doing. So we're doing the t. Well, to do the t, we need our degrees of freedom, right? So what was degrees of freedom again?
Isn't it -1? Something
Yeah.
-1.
N minus 1.
And
So
minus
100, 100 minus 1, which is
99.
99, right? So now this is where I bring in my level of significance. So my level of significance was 5%, right? And remember the symbol is alpha, like we always been using, so 5%. So I go back to step 1. I am doing a less than problem. So that means I am drawing my tail down here, right? Yes?
Yes.
Okay, good. It's 5%. So I color this in at a 0.05. Okay. Now, what do I do?
Find your pullout.
Find your pullout. So we go to our little trusty pullout. And I have how many tails?
1.
1. So I need to find 0.05 in the 1 tail row. Right?
Yeah. But there's no
And I
99.
what? There is no 99.
There
Yes,
is
this
no
is the issue
100.
with the tail. So what number should we use?
100.
100.
100. So we go to our 100. We go over to our 0.05, and we get a test statistic of
1.660.
1.660. Now, are we good right now before I go on?
Yes.
Yes.
Mm-hmm.
Okay. What is the issue?
It's on the left of the 0.
It's on the left of the 0. So which means this critical value should be a
Negative?
negative 1.660. The table doesn't give you both values because it's under the assumption that you realize the distribution is symmetric, so it can go either way. That's why I like to draw the picture. Because I know I'm on the left of the 0, then I know that my answer is negative 1.660. Does that make sense?
Yeah.
Okay. Now, our test statistic was negative 25.205, right? Where does that number go?
More to the left.
Yeah, way more to the left, right? We're somewhere over here.
Way out in La La Land.
We're way out here in the tail. Right? Is any part of it in the good spot?
No.
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 No. So we are rejecting the null. The only way we can fail to reject the null is if there is any part of it in the inside the good region. We have none of it inside the good region. So since we have none of it inside the good region, then we are failing. No, we are rejecting, not failing, sorry. We are rejecting the null. I almost said the wrong thing. So I'm trying to get off my draw page and kind of bring this up so we can kind of see all the steps. So I'll give people a second to look at that so we can kind of see how we feel about what we just did. So are you feeling okay?
Yeah.
Better
Okay.
than I did last class.
Good. So we're following. At least we get the steps. So that's why I went through the steps last class. Because if you kind of follow them, then we just kind of gotta pay close attention to our calculations here. So we reject the null, right? That's our conclusion. Now we need to put this back into something that people can relate to, right? So our conclusion. There is sufficient evidence to support the claim that USM, there's sufficient evidence to support the claim that USM students have a lower college debt to the average Maine student.
Bless you.
Thank you. I don't know why that's so small. Blow that up a little bit, probably because evidence is so zoomed in. All right, so any questions on how we went through the 6 steps? So just to reiterate, step 1, you determine your null and alternative based on the information from the problem. Step 2, calculate your test statistic from the pullout based on your population parameter. Step 3, draw a picture. Find your level of significance, color the proper tail or tails, depending on what type of problem it is, and then go to your chart and find your critical value. Then, once you have that, place where your test statistic value is, then use your picture to decide if you're rejecting or failing to reject the null. In this case, we are rejecting the null. There's our statistical conclusion. And then we interpret our results back to the problem. There is sufficient evidence to support the claim that USM students have a lower college debt to the average Maine college student. Now, we won't know if we truly made an error unless we actually talk to every single USM student, right? So what type of error, statistical error could we have made? Type 1 or a type 2? So we go back to, so remember, we reject the null was our decision, right? So we go back to our chart. We reject the null. So we are in the bottom row.
It could
So
be
if we made an error, we made a type 1 error. So if we made one, and again, you do not know, that's what's so weird about these errors. But if we did make an error, if we did make a hypothesis error, it would be type, and I can't type 1. Why is it? Oh, because I'm zoomed in so much.
Where was that chart you just showed us? Is that in your OneNote?
Yeah, it's on 8.1.
Okay.
Can I ask a question? How do you get to your OneNote? Because you can talk about that thing, and I've never actually used it.
Sent you a link a while ago. I can send you a link again if you need me to.
Okay, thank you.
Yeah, it should have been an old email. I can try to do it right now. I don't think I'll remember you. Let me see. That's you right there, Virginia, right? Go yet?
Yes.
Okay. So I'm going to change it not to edit. I want you to be able to look at it. Anyone else need me to resend it to them?
No, I got it already when I asked you to resend. Thank you.
Yeah. All right. So you'll be getting LinkedIn thing in the email. You just click on the link and it'll take you to my OneNote. And then you can download it to your OneNote, where it's part of the Office 365 software package that you get for being a student. All right. So if we go to 8.1, there's the table at the very bottom. So there's a full problem on how to do a hypothesis test on the mean. So now we've done a hypothesis test on a proportion. We've done the hypothesis test on the mean. Any questions? And check your mic, because I just hit mute because there was a lot of people on mute and a lot of background noise. So I just muted everybody real quick. So if you need to say something, just do another, unmute yourself. And I'll check chat, because for some reason my chat thing has not been popping up lately. I don't see anything in chat. Go back to my OneNote. So any questions on the two types we've done so far?
No.
And I'll leave.
Good.
Go ahead.
I just said no. I'm feeling pretty good.
Okay. And so if you want these OneNotes, I'd wait to after class to pull them, but definitely pull them because, well, I'll leave it for a full day. Take a few days because it's Thursday. But I will go through and erase all my notes on 8.3 and 8.4 because I use the same OneNote for my Monday class. But after I do my Monday class, I will leave all the coloring in for the rest of the semester. Now, good news is once I have all this built, you guys help build all this for the future classes, so they'll all have access to this in the future. All right, so let's move on then to A4. And the good news is the steps don't change. That's why it might seem like I'm going fast, but we're gonna go through all three types, and then I'll see how we're all feeling. I probably won't do the XL1 today. I'll do the XL1 on Tuesday. So 8.4 is a claim about the variance or standard deviation, but it's titled Claim About the Variance. So a professor tells his class that the average test score for exam 2 is a 90. A wise stat student that asked, what is the standard deviation of the test scores? The professor says a standard deviation of 8 points. The student believes that the 8 points is not the true standard deviation. So the student then asks 30 of the professor's past students their test scores, and they calculate a sample standard deviation of 9.2. So then the students conducts a hypothesis test on the true standard deviation of exam test scores at a 10% significance level. So, where's the key words here?
Wouldn't the keyword be average?
No. There's the word hypothesis test on the true standard deviation. That tells me right there what type of problem I'm doing. So it's a hypothesis test on the true standard deviation. So I go to step 1. I then, again, I have my null. I also have an alternative. What symbol is for the true population standard deviation?
That's sigma.
That's sigma. So I have sigma, and I have another sigma. My null is always equal. So we go with what everyone believes to be true, and that's what the professor said. So we believe the true standard deviation is 8 points. The wise statistics student does not believe it is that, right? But I still use the same value. But what inequality do I use here?
Greater than?
Okay, so I have a greater than. Anyone else?
I have greater than 2.
All right, so then my question to you is, why are you using greater than?
Because it says 9.2, which is bigger than 8.
True, the number is bigger than 8, right? But we have to be careful of that. We have to base it off the student's claim. What is the student's claim? The student
8
believes
points
that
is
8 points
not.
is not the true standard deviation.
Oh.
So therefore, what is my inequality?
It's not the not equal sign.
It is not
Yeah,
equal.
that.
So don't jump to conclusions based off the numbers. All right, your claim is what decides what type of problem this is. So since the student believes 8 points is not the true standard deviation, it is a not equals problem. Any questions on that? And then again, we have our lovely significance level, which we need to know to finish step 1. So we go to step 2. And it's a hypothesis test. So we go to our pullout and we go to chapter 8, because that's what hypothesis tests are. And we're doing it on the standard deviation. So our test statistic is chi-squared equals n-1 times s squared all over sigma squared. Right?
Yes.
So what is n?
The sample size.
Yep.
30.
30. So I have 30 minus 1. What is my standard deviation? What's my S?
8.
8.
No, that's my sigma.
9.2.
There we go. This is where you have to know your symbols. Because if you put 8 on the top and 9.2 on the bottom, you're going to get a very different result. All right. S is the sample standard deviation. That is the 9.2. 8 is the population standard deviation. That is the 8. And you can see that if you go to your null, the symbol sigma equals 8, which tells you that has to go in the denominator. Okay, so now we go to our trusty calculator.
4.16875.
All right, let's see. I haven't typed it in yet, but we'll see.
I was going to say, I haven't even gotten that far yet. So you're way
It's
ahead of
all
me.
over it. So parentheses, 30 minus 1, close parentheses, times 9.2 squared divided by 8 squared.
I got 38.3525.
I got 38.3525 as well. Anyone else get this number or not get this number?
Yeah, I got that number.
Okay. So there is our test statistic. We'll box that, so we'll come back to him. All right. So let me get off draw so I can move this up a little bit. Just a little so we can see everything. So I can keep my significance level, and there we go. So now I draw what distribution?
See, this is where I get hung up. I don't remember which draw is which.
So we are drawing a chi-squared.
Oh, okay.
Right? Because that's what our test statistic equals. And the key with the
Okay.
chi-squared, it's not centered at 0, it starts at 0.
Okay.
Okay.
Thank you.
And don't worry so much about the shape. The key is making sure you go to the right table, right? So I'm not going to be judging anyone's pictures. The key is going to the right table. And since it's a chi-squared, because that's what the test statistic says it is, then that is the table I go to, right?
Right.
So I now, again, 10% significance level, right?
Mm-hmm.
So I am doing a not equal. So how many tails?
Wouldn't it just be
2.
2. And not equal is a 2 tail. If I have alpha is my significance level at 10%, how much is in each tail?
5 in each?
5 in each. So I color this one. He's a 5%. I color this one, and he is a 5%. Right? Now what do I do?
Go to your chart.
The chart. What chart?
T
Mine's
chart.
full.
Oh, the chi
The
square.
chi-square.
There we go. And you gotta do all the flipping around that you hear me doing because it's on the weird page.
I was just say I can hear you flipping yours all around over there.
Yeah, they want to unfold properly for me. So we go to our chi-square chart, right? What do we need to read our chi-square?
Or degrees of freedom.
I need our degrees of freedom again. So it's again, that's n minus 1. So our sample size was 30. So our degrees of freedom is
29.
29. So I go to 29. And remember, a chi-squared reads to the right. So when I find the first 5%, when I find 0.05 at the very top, I get a chi-squared value of 42.557.
Mhm.
That is the number that goes way over here, if I can get my thing to right. Because a chi-squared chart reads to the right. Highlight that on the top, put stars around it. I don't care what you do. Just remember it reads to the right. So
Oh, I boxed it on my pullout.
Good. So how do I find this lower guy then?
Would you subtract it from 100?
You would. So you get 0.95, and I get a critical value of 17.708. Where does 38 go?
Wait, what are we subtracting from 100?
5% right here.
Okay.
So wouldn't that 38.3525 go in the middle?
Yeah, somewhere in here, right? So maybe about right there, right?
Sure, sounds good.
38.3525.
Mm-hmm.
How did you get the 17.708?
So we did 100 minus 5%, which gives us 95%, which in decimal form is 0.95. So find 0.95 on the top of your chart, come down to 29 degrees of freedom, and there is the 17.70.
Okay, that's where I was lost at too.
Yeah, because you got to remember, it reads to the right. And when we're reading, do we care about the far tail? No. All we care about is the lower tail. And since all we care about is the lower tail, I subtract 100% minus the lower tail. Let me check and see if anyone's got chat questions, because again, my chat's being crazy. Usually it warns me when someone asks a question, but it hasn't been lately. I don't know if they updated something and messed that up again or not. Okay. Where's my markings here? So, what's our conclusion?
Wouldn't we end up rejecting it because nothing's in the tail?
Remember, the tail's the bad region.
Oh, so then we would accept it.
Yeah. So we fail to reject the null is the proper way to say it. If you say the word accept, I'm not going to take points off. We fail to reject the null. And again, the only reason we say these words in statistics is we don't like to be wrong. So I didn't say I accepted it. So if someone proves it wrong later, then technically I'm not wrong. I just failed to reject it. So we fail to reject the null. So if I come in here and do my conclusion, right? We fail to reject it. Also, there is insufficient evidence to support the claim that the true standard deviation of test scores is not 8 points.
So this would, oh, I'm skipping ahead. Sorry. Just kidding.
Nope. That is my next question. What type of
Well,
error?
I figured
What type of error could we have made?
the type 2 error.
This would be a type 2. Any questions on anything we have done with hypothesis testing?
I feel better today than I did Tuesday. That's for sure.
I definitely do today as well.
I have one
Tuesday,
question.
my head hurt.
So say we only have one tail on something and the confidence level is 90%. Would that tail be 10% or would it still be 5%?
Nope. If you're doing a one tail confidence, which is something that is allowed, we won't do any in this course, but it would be a 10%. Yes.
Oh.
Yeah. Anything outside your confidence is the bad region. Now, depending on how many tails you have, tells you which part to color.
Okay, thank you.
Yep. So we still have a half hour. I don't want to do the Excel problem today because I think it'd be better to start that next class. So I think it's called Class Problems Excel. It's already loaded on the course page. We'll download that and we'll do a class problem. Start to finish from raw data all the way to the end. Probably take about half hour. And then we'll use the remainder of the hour for me to answer any questions you have on chapters 6, 7, and 8 for the test. I'll try to have the review up by then on Pearson. And then I'll have the test built by then as well. And we can kind of talk things through and make sure everyone's nerves are okay. But we have time, so if we want to do another one, or I can just answer questions, up to you all. Or we can call it early and maybe get outside and stretch your legs and get away from computers for a little while.
I think I'm all set.
Feeling very positive about this chapter so far.